Hello all, welcome to the video lecture series for the subject operating system. Now I'm going to explain you all about how this process synchronization technique, that is test and set, is actually working with, right? Let's say it is one of the hardware solution to this synchronization problem, right? Basically, this test and set is a direct synchronization solution where the either of the process can either wait or else enter. Let's say it will share a lock variable that is actually a true or false statement, that is 0 or 1, right? Like the Boolean factors. Basically, it is a process which checks whether any of the process, either P of I or J. For example, if P of I is actually checking whether this lock is either locked or else it is free. Say for example, the process will actually check the lock before it enters. If it is find that lock is locked, then it has to wait. That is put into the reminder section. If the lock is actually open, then it is getting entered into the process. That is critical section for execution. So we have a definition for this particular procedure. Say for example, the definition for test and set instruction. So now we have a Boolean condition. As we have the lock is either, we are going to find the lock can be either 0 or else 1. 1 in the sense it is locked, and true in the sense it is open. Well, I mean 0 in the sense it is open. Let's say for example how this lock is actually working. Now this Boolean test and set condition will have a data type. Say for example, this is a data type called Boolean, and here we have a function name called test and set. So this is the argument, that is a Boolean argument. We have this pointer target. Let's check, this is the described, or else we can say that it is a hardware solution has been described with a pseudocode. We are going to check that with the condition, right? One simple example to take this condition, how this Boolean test and set function works. Now say for example, here this is the data type, function name, and we are passing a argument that is called as pointer target, that is a Boolean argument, right? Let's say this is the argument, this is the function, and this is the data type. So all three has been set for execution. So we are finding a hardware solution where the two process, which process can enter and which process can wait. Now let's check, this is a Boolean RV. RV stands for return value. You can have any of this value with your own aspects. So I have made it is RV, that is equal to pointer target. Now let me tell you one thing. The point is, whatever this target value is, either this, that is the Boolean argument which can pass either true or false, whichever is applicable for this, the same will be reflected in this RV. Now say for example, initially we take that pointer target, that is the Boolean argument, is initially set to true, that is it is actually 1. I told you already, 1 in the sense it is true, and this particular critical section is locked. Okay, 0 in the sense it is false and it is open, right? I told you already in which condition if any process which is waiting outside the critical section can enter. One is if it is true, it is locked, the waiting process cannot enter. If it is false, it is open, the process which is waiting outside can enter, right? Now set for example, it is initially set to true and it will return RV. RV in the sense I told you already, whichever is applicable for this Boolean argument will be reflected in RV. Now it is 1, it will reflected RV. That is what? The RV will be thrown into this particular part, it will return RV. RV is initially set to target and the target value is true. Now the RV will be actually 1. So this is the actual procedure we have. We are going to see that how this procedure is executing with two different processes. Let's take process 1 and process 2. I'll explain this process 1. This is a direct actual procedure you can understand in one stretch. Now do and while statement here, do. So while test and set, open bracket, ampersand lock. So I told you already, ampersand lock will carry two values. One is 1 or else 0, right? 1 in the sense true. That means the process is approaching this particular lock has to wait. I told you already, which is described here. One in the sense it is already locked and some other process is inside. Zero in the sense it is open and you are free to go in. Now say for example, check that. Now lock is initially true. I told you already here, you can find it here. So I always said this lock target value, that is true. So here the target value has been mentioned as lock. So initially lock is set to true. The value is 1. So now P1 is approaching. Tell me, you can think that P1 cannot get enter because the lock is already locked. No one can get enter. If it finds 0, it can get enter. Now say for example, P1 is approaching and it cannot get enter because the value is initially set to true. Right. Now if it is the value, that is condition, whenever I'm checking the condition, it will break the condition when it is false. It will not break the condition it is true. Now test and set ampersand lock, it is initially the value is 1. So I cannot break inside. Right now I am not going to do anything. Right, the condition cannot be broke. Right, who is inside? P2 is inside. Say for example, now P2 is inside this critical section. Okay, now P1 is approaching, it is finding the test, that is value, that is lock is 1. So P1 cannot get enter. Right, let's check. When P2 completes its task, P2 want to leave the lit critical section. What will happen? Lock is equal to false. This P2 will set lock is equal to false. That means what? The value is what? 0. I was repeating the same thing I told you already. If the lock is 0, the process who is waiting outside can get enter. Now when process 2 completes its task, now process 2, once the process 2 complete its task, it will not hold the critical section. It will leave the critical section. That is actually the mutual execution, right? So lock, it will set the lock is equal to false, and in this P2 will get into the reminder section. That's it. When this condition will be always executing when this process is true. Now get enter into the next part. Again, you can check the right hand side value. Now P2 is approaching. Initially I have taken P1 and I was checking that who is inside. P2 is inside. Now say for example, next condition. If P2 wants to get enter, right? Who is inside now? P1 is inside. How to check that? You can check that while test and set ampersand lock. Ampersand lock is initially 1. I told you already. Now it holds the two condition, either 1 or else 0. Now say for example, it is 1. 1 means what? True. Who is inside? P1 is inside. Right? So if someone is inside, the process 2 has to wait outside. Right? So it is checking that value. P2 is getting enter. It is finding the lock is true. That means someone is inside. Who is inside? P1 is inside. So I have taken, for example, P1 and P2 so that you will understand how exactly this process works. Right? This is a hardware solution for synchronization problem, process synchronization problem. Right. If P2 is checking that P1 is inside, it is throwing the value as 1. So it will not break this while loop. It will break this while loop when the condition is false. So now it is true, it will not break. This P2 will not break it. So P2 will do nothing. P1 is inside the critical section. Now I will check this. P1 is inside the critical section. Now P1 want to get out once it uses the critical section and the process has been done successfully. So what will this P1 will do? It will set the lock into false. Now what happened for this lock? The value will make 1 into 0. Right? So now this P1 will get into the reminder section. Right? Now the lock has been set into false. Who can get enter? Who is waiting outside? So now P2 is approaching, it will check the lock is 0, then it will get into the critical section. This is how this set and test is actually working, right? It is one simple solution for process synchronization problem, that to set and test. I am testing if it is true, I wait outside. I am testing if it is false, I am getting inside. When I am getting inside, I am going to set this lock value into true. Right? So this is how this process 1 and process 2 is actually working. Thank you.